I'm going to show you a Matlab tutorial to plot these two differential equations, dA dt and dB dt. So I'm just going to put these over to the side for now. And the first thing we're going to do is just good practice in Matlab. We're going to clear all and also CLC. So this basically just clears the whole workspace, which is over here. In Matlab so that we have no variables are taken, we're not overwriting anything, and everything is basically a clean slate. So you can either do run section to do this and you see the workspace is clear, or run. Run is also acceptable. Okay, and then next thing to do is to set our constants. So note that when you put the % sign in front of something in Matlab, that becomes a comment. I'm going to set my variable little a is equal to 2 and little b is equal to 5. These are just arbitrary constants for the sake of this example. So to solve these ordinary differential equations, you have to define your span of time over which you're trying to look at it, which is relevant to the dt part of this equation. So for this, I'd like to set the time span between time unit 99 and 100. But this can be whatever time span you're interested in. This could be hours, days, 0 to 100, whatever you need. It depends on your equation and your application. And then finally, you need to set some initial conditions for your differential equations. So these initial conditions I've chosen to be 1 and 100 right here. So note in the last two assignments I've done here, I've made a 2-element array here. So this is a piece of data with a list of items inside. So for the time span, it's my beginning time and my end time. And for my initial conditions, this is my initial value for dA dt, or for the variable of a at the beginning of the time span, and 100 is the value for big B at the beginning of the time span. Okay, now we are ready to call our ordinary differential equation solver, which is ODE45. So I'm actually going to not do this at the moment because we actually need to put in our function here. So to make a function, we have to define our function with the word function, and then our output value, dA dt, I'm just going to use dA dt as an array to hold both big A and big B together, the values for both. And I'm going to call this function ODE fun, or ODE function. We'll accept our time variable, our actual value y, and our constants little a and little b. So this is a function for the system of ODEs so that we can actually put in our equations that I just showed at the beginning. So we're going to initialize the dA dt value with just 2 zeros. And I'm going to put in the function zeros, which just creates an array of a size you want of zeros. So it asks for the dimensions, which is 2 by 1, and this will create an array of zeros. Then I'm going to actually put in my equations. So for dA dt, big A, dA dt, that's the first element in my array. I'm just going to call big A the first element in that array. And that will be little a times big A evaluated at t, which in this case we will call y, y1. Y is our evaluation of a at t. So note that this is a differential, and this is the actual variable big A, big B. So y1 is calling big A. And then we're going to fill in the rest of our function, times b times big B evaluated at t, which again I've defined as y of 2, right? So I'm going to say y is equal to a evaluated at t, b evaluated at t. And dA dt is dA dt dB dt, evaluated at these particular times. Okay, so now I'm going to put in the last equation, which is dB, dA dt2. Now remember, we've defined dA dt, the second element in that array, to be dB dt. So this will be A times B of t evaluated at t, which is again y in the second element of that array, minus B times A evaluated at t, which is again y of 1. So note that this is a system of ordinary differential equations because they call each other. These variables call each other. And then to end the function, you have to put end, and this defines our ordinary differential equation function. Now, back to running ODE45. We're going to call the function ODE45, and then we're going to give it a handle to our function with the variables. So to give it the variables, we'll do at t and y, and then we'll put in our function name, which is ODEFun, and then put in our variables plugged in here. So this section is essentially a handle to this function with these variables to be evaluated. And then we have our variables for the time span, we're looking at t-span, as well as the initial conditions. All of these elements are necessary to run ODE45. And we also need to return the time vector, which I'll call t, as well as the actual result of all this, which I'll call big A. So these two will be the return vectors. So these essentially represent the time vector, so a whole bunch of times between 99 and 100, and the big A and big B evaluated at each of those time points. So this will be an array with two rows. One will be big A evaluated at those times t, or big B evaluated at those times t. Now, we want to actually plot this, so let's first open a figure, which is simply done with just figure, semicolon. And then we will need to do a subplot. So, because I want to plot big A and big B separately on two separate plots, but on the same figure. So to do that, I'm going to do subplot 1, 2, 1, essentially saying I want a 1x2 figure with two plots on it, and I'm currently plotting in plot 1. So I'm going to plot the time span t as my x variable, and then y colon 1 as, A colon 1 as my first plot on the left. So A colon 1 represents the entire the entire first column and all of its associated rows. So let's just plot this so I can show you, right? So when we returned A, we returned a 57 row, 2 column matrix, and the first column is entirely variable A. So that's why I called colon, comma, 1. Now let's plot variable B, so subplot 1, 2, 2. Note that these two numbers are the same, so a 1 by 2 plot, but this is different too. This indicates we're in the second panel now. So now let's plot T, A, colon, 2. So now this is the second row. So this represents big B relative with respect to time. So now let's plot that. There we go. Now we have our 2 plots. But these plots don't really mean anything. Let's add some titles and labels. So to add a title, just say title and then whatever title you'd like. I'm going to call it variable A. And now for the other one, I'll do variable B. And then let's also add some axis labels. So you'll do this by X label. I'll call the X label time. And Y label, let's call this just A. Let's do the same thing for the other one, X label, time, and Y label, just going to call that B. And let's run that. And there you go. Now we have our plots for these equations, these differential equations, and now we have used ODE45.